Alright, welcome back. What we just found were the 6 trigonometric ratios of a right triangle for a given angle of reference. The section next says ratios for special right triangles. I created a bonus video after you watch the required videos. You could look at this video to teach you how to do this. These were part of the setup lesson of our prerequisite skills and how to label these right triangles, and you learn that in geometry. Special right triangles have acute angles that are 30, 45, or 60 degrees. 30, 45, or 60 degrees. We can find the trig ratios by using these two triangles and nothing more than that. And again, simplifying, rationalizing. So let's skip ahead to our next section. I may not do all of these exercises, but I will do a few of them. The directions are going to say, what we want to do is use your calculator to solve triangles A, B, and C. To solve a triangle means to find all the missing pieces and measurements to it. And we can't do that unless we can see our triangles here. The directions say round to the nearest hundredth. Now what you'll notice is that the vertices of the triangle uses capital letters. I've marked side length little a and little b. Because the directions ask us to find little a and little b, I've marked them A and B. You'll always find the side length across from your angle and name it according to that. So if this is capital letter A or angle A, this would be the length that corresponds to that, or little a. Same thing for capital letter B is the angle, little b is its corresponding side length. The easiest thing to do for us is to find the measurement of angle B. If you can read this right now, it says 30 degrees, that's 90 degrees. The three angles in a right triangle, or any triangle, always add up to be 180. So we're going to subtract 90 and 30 from 180 to get that measure of angle B is 60 degrees. That was the easy part. Now let's find A and B. Now what we're going to use is the information we're given. We're given an angle, we're given a hypotenuse. A is what relation to this angle? Is it opposite? Is it adjacent? Well, I know it's not the hypotenuse, it's the opposite. What trig ratio uses opposite and hypotenuse? That would make sine. Let's do the sine of 30. So this is your setup. The sine of 30 degrees would be the ratio of the side length A divided by 10. What you're going to do is you're going to multiply both sides by 10 and solve for A. 10 times sine 30 degrees equals A. Now the directions say use your calculator and round to the nearest hundredth. So let's do 10 sine 30 degrees. Now hang on a second. Before I hit enter, I want you to do the following. If you have this graphing calculator, I want to make sure you find this mode button. You find this mode button, and here you're going to need to make sure your calculator is in degree mode. There's another way of measuring angles, which is called radians. If radians is selected, just arrow across onto degrees and hit enter. Let's go back now that I know I'm in degree mode and hit enter. We get the answer is 5. Because this has a units to it, we're going to write 5 centimeters. That's how you would find the length of little a. What's little b? This reference angle is marked as 30 degrees. The hypotenuse is 10. B is the adjacent side. We're going to use adjacent hypotenuse, so ka. We're going to use cosine, ka. The cosine of 30 degrees is equal to B divided by 10. Multiply both sides by 10 to get little b, the length of side length B. 10 cosine 30, and we're already in degree mode. We get 8.660 if we're rounding to the nearest hundredth, 8.66. This is okay for now. The previous video would have told you that this would be exactly 5 root 3, because this is a special right triangle. If I in fact type in 5 root 3, I get the same answer. Okay, this one is exact, but we don't know how yet to do that. I'm going to move on to exercise 5 and then maybe skip to number 7. Now 25 degrees does not make this a special right triangle. What we have given is we have an angle, we have an adjacent side, we're missing the opposite and the hypotenuse. So we want to take advantage of knowing an adjacent side. Angle B one more time is probably the first thing I want to find. If 25 degrees is the measure of angle A, then subtract 90, 25 from 180 to give us 65 degrees. is the measure of angle B. Actually, I think that's not right. It should be 65, let's see, 90, 115. No, actually, I double back. I think that is okay. So this is our measure of angle B. Let's find the length of C and A. It does not matter which one you use first, but just make sure that you have set up your question correctly. 25 degrees, we know the adjacent. If you want to know the hypotenuse, adjacent and hypotenuse uses ca. We're going to use cosine. The cosine of 25 degrees is equal to adjacent over hypotenuse, 12 divided by C. What we can do is to multiply both sides by C, or cross multiply even. We could do that. Cross multiplying might be easier. 12 times 1 and C times this. Either way, it's the same thing. We're going to get C times the cosine of 25 degrees equals 12. To find the value of C, we're going to divide both sides by the cosine of 25 degrees and evaluate this with our calculator. 12 divided by the cosine of 25 degrees, and we get approximately 13.24. The 0 would round that up. In the units, looks like it's centimeters, so centimeters it is. Now the measure of length A is opposite of 25, and we know the adjacent, so we know opposite adjacent, so ka-toa, opposite adjacent, tangent. We're going to use the tangent, 25 degrees, is opposite over adjacent. Okay, this one's a little easier. All you're going to need to do is to multiply both sides by 12. 12 tangent 25 degrees equals A. Using this calculator, 12 tangent 25 degrees, we get approximately 5.60. Please round correctly, centimeters. It's because our next digit, our thousands place, is a 5. We're going to round this up, which rounds this up again. Okay, so that solves this triangle. I'm going to skip now to question 7, where we don't have a picture. There is no shame in writing the same triangle each and every time. We know this is a right triangle because one of our angles is 90 degrees. You could just draw any general right triangle as long as you label it correctly. I made C the 90-degree angle. Let's see, A looks like it's 71 degrees. I might put A up here, B down here. You can switch it around as long as, again, you label it correctly. The easiest thing to do is to find the third angle. So what's left over? I think that would make 19 degrees, the leftover angle right here. So let's put 19 degrees in for angle B. I have one side length. The side length I was given was C equals 20. So across from angle C, we'll make the hypotenuse 20. So now what? We need to find the length of little a and the length of little b. Now something I haven't told you about, the length of A and the length of B are matched to these angles. Which side should be longer, A or B? Because it is across from the larger angle, the length of A will be larger than the length of B, which is across from a smaller angle. What we're going to use to find the length of A, I'm going to use the given information of 71 degrees. So A is opposite of 71, 20 is the hypotenuse, opposite hypotenuse. So we're going to use sine. The sine of 71 degrees is equal to opposite over hypotenuse. Multiply both sides. Multiply both sides by 20. This gives us the value of A. Here's the calculator. 20 sine 71 is 18.91. And I don't remember if they have a units. They didn't give me a units. Let's just put units for length. Now letter B, side length B is the adjacent. We have adjacent hypotenuse cosine. Why am I using cosine? Because adjacent hypotenuse ka, and so katoa. The cosine of 71 degrees, you have to input an angle, is B over 20. One more time, multiply both sides by 20. And this will get us our length. This is going to end our video, but again, there's another one coming shortly, right after this. B is approximately 6.51 units. What we suspected was true, that because this is opposite a smaller angle, its side length is going to be a lot smaller. I'm going to skip. You can finish 6 and 8. Maybe I'll put that answers to that later. Why don't we move on to our next video?